Hi, everybody. Welcome to Demo, the show where companies come in and they show us their latest products and platforms. Today, I'm joined by Matt Fuller. He is the co-founder of Starburst. Welcome to the show, Matt.
Thank you.
I love the name of the company. It's just a fantastic name. So tell us a little bit about Starburst and then what you're here to show us today.
Yeah, absolutely. So Starburst is an open data platform to power both data apps and AI. So you can think of it as being able to run queries, whether you're using traditional BI tools like your Tableau, Power BI, but we're also seeing a lot of use for people who are trying to build data apps or power their AI applications.
All right, so I heard the word data, so I'm assuming that this is designed for data scientists, data analytics, anybody that's dealing with data, or is it something where everybody in the company can kind of gain benefits from it?
Yeah, absolutely. So just a little bit, let's double click into a little bit of what our platform ultimately is. So it's based on an open source project called Trino, and that's when we founded the company back in 2017. That's what we built the company around. So Trino is an open source distributed SQL query engine that can connect into various data sources. So that's a component of our product. We've built an entire set of capabilities around that to really help data engineers or those building AI applications, or sometimes we call them data producers, but basically to get access to the data and kind of stitch prepare the data for ultimately the data consumers. The data consumer could be human-led consumption like Tableau, Power BI, or it could even be kind of more machine-led consumption, say from a data application or an AI agent, for example.
And what problems are you solving? Obviously, you wouldn't have formed the company if you weren't there to solve a problem. So what are people seeing out there that you guys can help with?
Yeah, absolutely. I think a few things. So one is the ability to get to the data where it is. So we're a really powerful engine for querying data from the lake. But often some of the challenges are, how do you get the data into a single place? So we can further augment that data to reach out into different locations. Because at the end of the day, especially with the growth of AI, your AI is only going to be as good as the data that you provide to it. So we like to think of ourselves as being that kind of fuel to fuel AI. So the ability to get into different data sources without having to wait to have it centralized in one place and then actually use it. So really quick, kind of experimentation, and then going from experimentation to production really quickly. The other is uniquely, we can also run on-prem and also get data on-prem as well, where there's a huge on-prem footprint of data, including the cloud as well. So we can not only connect to different data sources, but whether it's on the cloud or cross region, or even back to on-prem, we can get to that data.
Was the growth of the cloud really the reason why companies started getting their data in all different locations, because I've heard of a couple of other companies that do this too, and is that the reason why a lot of this data wasn't centralized, because there were so many things that moved to the cloud?
I think there's probably a few reasons.
Yeah.
One is kind of that technology shift to the cloud, but you still have your legacy data on-prem.
Yeah.
But also there's other reasons. There could be privacy or security reasons why you want to keep it on-prem, or in larger companies are doing M&A acquisitions. You might acquire a company that just had data in Google, but you're an AWS shop. Or you just had legacy data on-prem, or you intend to keep it there. So there's a whole variety of reasons why that happens.
So if a company out there wasn't using this, what problems would they be having? What would they be doing instead? Just a lot of manual stuff or time-consuming things?
Yeah, I would say a few things. So definitely you have to use more tools. You probably have to be more reliant on ETLing everything into a single place, where ETL definitely has its place for when you want to put it from point A to point B. But we don't make it a requirement. You can connect into the data source, experiment, figure out what you want to do. You could even just run production against that system if you want, or you could decide to move it to one place. But the thing is, we're giving that optionality to choose, so you really get that time to value much quicker with less tools and less complexity.
All right, so let's jump right into the demo and see what you got.
Yeah, absolutely. So let me jump over to here. So I'm going to show a few things. What I'm going to show is we're connecting into a bunch of data sources. And in this particular demo, I have generated data about, pretend we're like an airline or a travel company or something like that. And we have data in a variety of different locations. So first, let me show where we're all, what we're connected into here. So, a few things here. We're connected into Mongo. So we have some customer profile data in Mongo. In our Postgres database here, we have some data related to, let me just expand this out.
Sure.
Ancillary purchases, the loyalty program. We have a connection to Salesforce for customer service engagement. And then here in what we call the Ice House, we have data for kind of bookings history or even historical flight history. So we have all this data spread out through.
And this could be in locations around the world, in several buildings.
Exactly.
Yeah.
And in fact, some of these are in different regions. I just happen to know the Postgres is in US East 1 at AWS, and the S3 data is on US East 2, I think. So could be anywhere, but you have this one centralized view. Now, if you want to run queries against this, it can get a little tricky. Let me go to my query editor here. Now, you can use any tool you want. You could use Tableau, you could use Datagrip, whatever you want. I'm just going to use the UI here just for simplicity purposes. But in this particular query, I'm joining together Mongo data against some Postgres data, against some bookings data. And so you can see that I'm joining all together and just counting the rows there. Now, that can be a little bit tricky because you can see here how I have to cast some of the column types, and I have to do some manipulation of the data, but also I have to know it's in Mongo and so on and so forth. So we have this concept called data products that really make it simple. So it kind of creates this layer above all the complexity of this. So now your data engineers can set up what's called a data product. And from there to the end user, it just looks like a bunch of tables. They don't actually have to know that this table's in Mongo and this table's in Postgres. It just looks like a set of tables.
Yeah. So
let me go here. So we have a nice little search capability. So let me look for my customer 360 here. We can go to results. So you can search anything through. You can kind of think of this as a catalog, but it's more than just a catalog because we have access control and the ability to process the queries as well. But there's this nice search capability here. So we have my data product here. Let me open the details. And so you can see that, oops, I went into the wrong place here. Here, let me get to it through this way. There we go. So you can see here the data product itself has a bunch of descriptions about how to use this, and then it also has the associated data sets with it. So ancillary purchases, bookings, customer service, and so on. So from the end user's perspective, it's all in a single place. So I'm going to go to, let me look at what's the best way to do this? Okay, let me do this. Here we go, that's what I was looking for. So the other thing I can show too is we have the ability to tag PII data and so on. So this can be useful. I'll show in just a moment how this can be used for access control. So we have this nice view of the data, and let's just say you want to run some queries against this data product here. So I have some example queries. I'm not going to run them all, but you could ask questions like, what are the top 100 high value customers by total amount spend? We can run this. This is running a query against the data that's in customers on Mongo against the data that's in bookings that's on AWS S3, and you can see that we got a result here.
Okay.
And you can and so on and so forth. You can kind of keep doing this, and then you can even get to really much more complex queries, such as this. This query shows kind of the most frequent routes enriched with delay statistics, so on and so forth. There's a lot of rich information in here. But the other thing I want to show is if we go back into here, we can show that we also kind of track the lineage as well. So the other thing I wanted to show is, now that I kind of showed the data itself, one other neat thing is we have an access control system as well. So let me go back here. So if we go to say, I'm going to change my role. So I'm going to say, okay, now I'm the data engineer. So if I run this query, we can see here that when I'm querying this data product that has the customers, we're saying the full name, email, and so on. But if I switch to a different role, let's say I switch to an analyst role. So I'm a super admin in here, so I can kind of switch between roles. So now I'm pretending to be an analyst role. And you can see now that I had a policy that masks out the data. So this is really cool. So how do we actually do that? Well, we have a fully baked in access control system here. So if we go to the analyst role, we go to policies, we see that there's a policy here that will hash out the data that I showed earlier that was tagged with the PII column. So really cool where you don't actually have to copy the data. We're applying these policies.
Is that what a lot of companies will do? They'll end up copying the same data and then
sometimes, yeah. And so this allows you to kind of do it on the fly. That's also the other benefit of the data product is you can expose these to your end users. So there's these fully governed, highly curated data products that can be trusted. You don't have kind of this data swamp of, oh, there's a subset of the data over here, a subset of data here that you keep kind of creating. You can kind of apply these access control policies on it. So what else? So the other thing I can show is, I kind of breezed over this earlier, but what's happening behind the scenes here are these queries are running on clusters. You can think of this is a Trino cluster itself. Behind the scenes, we have our own enhanced version of Trino, which is the SQL processing engine. So I'm running those queries. It's running through our cluster that's run the query, and it might push down pieces of the query to say Mongo or Postgres or so on. But we're our own processing engine itself, and that's how we're processing the results. Actually, the final thing I want to show here is let me go back to where I was. So we go to flight history here. We also have the ability to, again, when I'm saying we're creating data products, we have the ability to create like kind of data quality checks. So you can see all sorts of stats about your data. But I also had a rule here. There's a column in that table called delay reason if the flight was delayed. And I want to make a rule that says like this really should not be null, more than 10% of the time. Okay. And in this case, it's passing. So really, if I were to summarize this, our product has the ability to connect in different data sources, and kind of create this like a data product. In this particular demo, I showed creating a customer 360. Next, I want to show some new functionality that we have. So earlier I showed this flight history data. And so one of the things we've just released is the ability to invoke LLM functions through SQL and also do vector search. And the novel thing we're doing here is we're storing what are known as the vector embeddings. Those are what are used for the vector search. A vector search is about getting meaning of the data. We're actually storing that on the lake inside an Iceberg table. So typically you might use a vector database to run this. We're actually storing the vector embeddings alongside the lake, alongside the data, just to kind of keep it simple. And we can do a search from that. And then what we can do is we can use the results of that search to call into an LLM prompt. And this can be used as part of a RAG pipeline, for example. So the retrieval of the data through semantic search and then augmenting an LLM with a question. So this is new functionality that we've just added into the product. So let me just show an example here. The first thing I want to show is what is an embedding? So we have an embedding in the Iceberg table here. You can see it's just a multi-dimensional array of numbers. It's just a bunch of math.
We're in the matrix now.
Exactly. So how did we do that? Just for the time and the purpose of the demo, I'm not going to run this, but we basically have a generate embedding function that takes the text. The delay reason is actually the text. We're running this against a model, in this case, Bedrock Titan. The other neat thing is you can configure this to talk to any model you want. Could be AWS, Bedrock, or even if you're running your own, model serving platform as well, with various models on it as well. So it's very configurable. And so what I'm going to do here is I'm going to run a query that says, which delays were caused by heavy rain. So it's going to use the delay reason and then try to retrieve the results that were caused by rain. So I retrieved the 100 results here. So that's pretty neat. You can kind of ask a natural language question, and you can imagine if you're building a data or AI app that this SQL is being sent to us and doing the processing itself. Right. Now, in this case, we're going to do the same thing where we're asking for data to come back, caused by heavy rain. But now what I'm going to do is I'm going to create a JSON document from it. This is all standard SQL. And then I'm going to feed it into an AI prompt. So you can think of this as like ChatGPT. And it says, the following flights were delayed due to weather. Can you provide a possible explanation based on the route? The data for the flights is provided in JSON. And so you can see that because we have access to various amounts of data, we can be used to fuel a customer's AI strategy because we can feed this in, and we've made it simpler by calling out to LLMs directly within our SQL, and you can build your agents and other applications on top of us. And so you can see here it came back with a potential reason, which is based on the flight data, there are several weather-related explanations, and it kind of goes through widespread weather system. It was taking a look at the different airport routes where there's weather delays are susceptible, and it kind of just goes through a variety of reasoning. So that's I just wanted to kind of show kind of the latest and greatest that we're out with. Yeah.
Cool. And so where can people go to kind of get more of their hands-on onto this? Do you offer a free trial? Is there
Yeah, the easiest way to get started is you go to starburstdata.com. And you sign up for a free trial. So Galaxy, when you sign up, you get some degree of free credits that you can use, and hopefully you like it, and we'll sign up and be a paying customer.
All right, Matt Fuller, thanks again for joining us on the show.
Yeah, thank you.
That's all the time we have for today's show. Be sure to like the video, subscribe to the channel, and add any thoughts you have below. Join us every week for new episodes of Demo. I'm Keith Shaw. Thanks for watching.